Hello and welcome to another Advanced Skeleton video. In this video we're gonna take a look at debugging of the face setup. Some of you might have been trying the Advanced Skeleton face setup section and encountered an error as you're trying to build a face. In this video I'm gonna show you some steps to take to help identify what can be the problem and get the face rig build process working. Now the first thing I recommend to do is to actually run the build process on one of the sample characters. Now doing this just helps you to make sure that the error is not coming from the code itself, but rather specific to the particular model you're trying to build on. Now to build a face setup on a example character like Tuna here, all you need to do is load up the character, go into the build section, hit toggle fit advanced, and we're gonna delete advanced. That completely deletes all the advanced face setup but leaves you with all the fitting elements intact. Then, in order to make sure the tools is building successfully itself, we're gonna hit Build Advanced Face button. Once you've confirmed that that fully works and builds successfully, you can go back to the particular model that has the error, and we're now gonna look at some of the most common causes for build fails. Number one common reason is non-default transformation values. And how to check for that is you select your face geometry and take a look in the channel box. Make sure all these values are all zeros for rotations and translations and ones for all the scales. Now you might have this geometry inside a group, which might be in another group, and so on and so forth. So to check it all, you can just pick walk up to go to its parent and keep looking at the channel box. Make sure these are all zero. In this case it's all correct, but what you might find as you have a look at your model is that you see values over here in the channel box, which means you have non-default transformation values, and that needs to be resolved. Now to fix such an issue, I recommend using the model clean tool that you'll find in the pre-section. Now the second most common cause for a build fail is that the model has construction history associated with it. Now to check for that, first let's again switch back to the fit state so that we can have a look at what we see when we select it. And over here you'll see the only construction history associated with this geometry is a single skin cluster. You might on your side see additional nodes here that could be things such as a poly smooth node or other construction history nodes such as poly split, poly merge, etc. These can also cause fails to the build, and the recommended way to resolve this is with the same model cleaning tool. This will remove all construction history as well. Next is the third most common cause for build failures, and that is non-symmetrical models. Now if your model is asymmetrical from either a purposely designed point of view or it is accidental from the modeling process, this can cause fails to the build, as the process will struggle to find corresponding vertices from the left to the right side. Now a quick and simple way to test the symmetry of your model is to simply select the model, duplicate, then apply -1 in the scale x-axis. Now this model is symmetrical, so we're not seeing much of an effect, but not to demonstrate, I'll purposely shift all the points slightly to the side. And now you'll see what it looks like when you do this test. Now if you find that you're having this problem, you will need to go back to your model and resolve the non-symmetry. So let's say everything on your model has checked out so far, and you're still encountering errors as you run Build Advanced Face, then it's time to start digging into the Step Builder. Now the Step Builder will help us identify exactly which step along the process where the error occurs, and we will now take a look at what some of those might be. After running the eyeball step, which is step number 4, I recommend that you test the direction of the eyeballs by just moving these controllers. And after running step 5, the eyelid, it is important that you see this selection around the eyelid that is now containing all the vertices that will be affected by the blinking. And after step 7, it is important that you are in fact left with an object that represents the forehead of the character. If this is not the case and you have an object that is nearly the entire face of the character, it means these curves are simply not running close enough to the surface to provide a clear cutout area. And what I recommend doing now is undo the cutout step and then closely inspect the curve points to make sure they are running near the surface. Now, if at any point the curve deviates far from the surface, you just edit the control vertices of the curve to make it run nice and snug close to the actual face surface. And then once again run the 7th step. And you might keep doing this, refining the curves until you get the correct cutout area object. Now the next step to be run is the end-clot simulation. Before running this, I recommend testing the simulation by hitting the play button. At this point you might find that this object appears to be fully exploding because the end cloth is failing to compute the result. If that's the case, I suggest tweaking some of the end cloth objects and parameters. Now I usually recommend starting with the parameters of the nucleus object, which is the main end cloth solver itself. And often end cloth that fails to compute might be resolved by simply increasing the number of substeps per frame. If that doesn't fix the problem, I suggest having a closer look at this particular end cloth constraint. This one can be tricky for the machine to compute because this is the step where it computes the skin colliding and sliding over the skull effect. Now, to identify if this is causing the problem, you can first try disabling this altogether. And you might find that that solves the problem. However, running it with this one disabled will have less of the skin sliding over the skull effect. Also, after running step 10, it's important that you can see this selection being all the lip vertices selected. Note that after running the jaw step, you can actually edit the set-driven key, which is the relationship showing how much this mouth controller drives the jawbone. And it's driving the jawbones both in rotate X, translate Y, translate Z, and scale X. And you can here define exactly how much you want this to be driven. And we'll now just complete the rest of the steps. Hopefully this video has given you some pointers to go by if you are encountering any troubles with the face build. I hope you have enjoyed this video, and I will see you next time.